Buddies, welcome back. We're at worked example 5 now. It's saying the ages x years of 18 people attending an evening class are summarized by the following totals. So anyway, we've been given some totals. Then they say calculate the mean and standard deviation. Ooh, you're gonna say to me, well, where's the data? Where is the data? Because I know how to get mean when I have the data. I need to see if there is a frequency distribution or if it's not there, and I need to see if the in the frequency distribution if it is ungrouped or grouped. But well, I don't have all that. So which formula am I going to use for mean? Well, don't make it too hard. All you got to do is look at the totals you've been given and use the mean that goes with the totals you've been given. So right now you can be able to calculate the mean. I mean, somebody would be asking me, why is it that this mean thing is always the standard deviation? They go hand in hand. That's the reason. Mean helps get standard deviation. So these two are partners. They work together. So right now we have these totals. So anyway, if they say calculate the mean, then we're going to just use the total that we have. Okay? Then we go for the mean that goes with the total that we have. Right? Exactly. So I'll check. Let's go and check our MF19. And here is the mean, right? I'm sure by now you're well experienced. You know how to see your mean. Here's the mean x bar. And we use this one because it's the one that is summation of x, right? So that's the one we're going to use. Let's go ahead and let's do it. So all we're going to do is we're going to say our mean x bar is equal to summation of x over n, which is equal to, now we just substitute. This total is what? 745 over, what is n? How many do we have? 18. So over 18. Then we can be able to get it now. So we say 745 divided by 18. You get 41.388888. So it'll be like 41.38888. So 38 recurring, and you just write it as 41.4 if you round off to 3SF, right? But this 41.38 recurring is the one we might use if we go for standard deviation now, because we would now say standard deviation, SD, will be equal to, we choose the one that goes with it, right? We have our standard deviation formulae here. Which one goes with it? It's obviously the top, because we've used the mean at the top, so we use the standard deviation at the top. These bottom guys are out, the bottom mean and the bottom standard deviation. And which one are we going to use on these two? Of course, we use the second one, right? The calculation one. I mean, it goes hand in hand with the total that we've been given. So let's go to it. It's summation of x squared over n minus the mean squared. So we would say it's equal to square root of summation of x squared over n minus the mean O squared. And we have the summation of x squared. So this is going to be equal to the square root of, what is the summation of x squared? We have 33,951. So it's going to be 33,951 over n is the number of people. And we've been told that 18 people attended the evening class. So it's going to be divided by 18. Then we subtract the mean. What is the mean now? The mean was 41.38888. We can say 41.389. We can put it like that so that we kind of try to increase the number of significant figures. Now, what do we say now? We say 33. Okay, I'm going to square this. And I'm going to say 33,951 divided by 18. Then I'll subtract that solution when it's squared. I'll get 173 blah blah blah. Then I'll square root it. I'll get my answer as 13.15775 blah 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 1578, which rounding off to 3 significant becomes 13.2. Here's my standard deviation, and I am done. Now let's see this one. It says part 2 says one person. Let's do part 2 in the next video. Bye for now.